Okay, during a game of totem tennis, the ball of mass 150 grams is swinging freely in a horizontal circular path. The court is 1.5 metres long and is at an angle of 60 degrees to the vertical as shown in the diagram. Calculate the radius of the ball's path. Okay, so our radius is there. How are we going to solve that? Trig, yep. So, you guys are too fast for me. So what have we got? We want the opposite and the hypotenuse. So that's sine. Sine 60 is equal to, call that, oh, I should have called it R. Let's call it R. Is equal to R on H. Yeah, you're right. So 1.5 times sine 60 will give us the radius. And that is what?
1.3.
1.3? Cool. So we have a radius of 1.3 meters. Okay. So now, I could have showed you this on the last slide, but I want to show you in this worked example. For part B, draw and identify the forces that are acting on the ball at the instant shown in the diagram. Okay. So, what forces are acting on our ball at the moment? Tension, absolutely. So our tension force is in that direction, upwards and to the left. There's our tension force. What else is acting on the ball? Gravity. Gravity is there. Now look what happens when we add those two vectors together. We get a centripetal force. Okay, when we add those two vectors together, we get our resultant net force, our centripetal force. Okay, so even though the tension is not in the same direction as the centripetal force, it acts with gravity to make that centripetal force. Okay, so those are the forces acting on it at this time. And I'll call this F net. Determine the net force that is acting on the ball at this time. Okay. Oh, I gotta think about this. How are we going to do this one? Net force. We have. Yeah, that'll work. We've got. All right. So we don't know our velocity. We don't know our radius. Basically, we don't know anything we need to calculate our net force, except. Oh, we do our radius. Yeah. Yes, we do. Okay. So what we would have to do in a case like this is draw a vector diagram. Okay? So we know our net force is acting inwards. We know mg is acting downwards. And we know our tension force is acting up and to the left. All right, we also know the angle between our tension force and mg is 60 degrees. How does that help us?
Well, we can find mg.
We can find mg, absolutely. So, mg is equal to, what was it, 0.15? Multiplied by 9.8. So I get 2.2.
Yeah.
Really? What did I do? Hey, I did 1.5. Sorry, my bad. Yeah, it doesn't look right, does it?
About 1.5.
Hang on, 0.15 times 9.8. 1.47. No, I'd keep 1.47. So remember, in your working out, keep 4 significant figures. In your answer, you can do 2. Okay. So we know mg is 1.47. We want, what do we want? The net force. So we've got the adjacent, we want the hypotenuse, we want the opposite. So tan theta equals opposite on adjacent. So our opposite, which is our F net, is going to equal mg tan theta. So 1.47 multiplied by the tan of 60. .5, excellent. Yeah. So 2.5 newtons is acting on the ball. And then we want the size of the tensile strength in the cord. We can use our trig again. So we have, again, from earlier, we've got mg. So we've got the adjacent, we want the hypotenuse. So cos theta is A on H. We want the hypotenuse, so H is going to be equal to A over cos theta. So I shouldn't use A because that looks like acceleration, doesn't it? Never mind. Adjacent is 1.47 over cos of 60. .94. So our tension force is 2.94 newtons.